Where is geotechnical engineering heading? This report presents a data-driven analysis of 1,257 papers from the 21st International Conference on Soil Mechanics and Geotechnical Engineering, ICSMGE 2026, held in Vienna, Austria. We look at where this research is coming from, what it's about, who's doing it, and where the field is headed next. Every technical paper accepted to ICSMGE 2026 was classified by author affiliation country, sector, and technical subfield. In total, 1,257 papers analyzed from 82 countries across 21 technical subfields, with 52% of all papers authored entirely by academia. Four forces stand out. The energy transition is pulling research offshore and underground into geothermal ground. Established economies are consolidating around numerical modeling and digital monitoring of aging infrastructure. Seismic exposed regions across Asia-Pacific and the Americas continue to anchor the discipline's core work on liquefaction and dynamic soil behavior. And academia remains the field's dominant author base, even as cross-sector, industry-linked research grows. The methodology followed four steps. First, extract, title, authors, keywords, and full affiliation blocks were parsed from all 1,257 papers, identifying each paper's country of origin. Second, classify. Each paper was matched against a 21-category geotechnical taxonomy, and each author affiliation tagged as academia, industry, or government and research institute. An independent, unsupervised analysis grouped papers purely by shared terminology, surfacing emergent themes that a fixed taxonomy might miss. And fourth, map and cross-tabulate. Country, region, sector, and subfield were combined and plotted geographically to show where each research theme and author type is concentrated. This is truly a global conference. Bubble size here shows the number of ICSMGE 2026 papers with a primary author affiliated in each country. The 24 leading countries are shown by exact geography, while the remaining 58 countries each contributed between 1 and 11 papers. A separate inset zooms into Europe, where contributor density is highest. Looking at the regional split, Europe contributes nearly half of all papers at 48.9%. Reflecting the conference's Vienna venue and the sheer density of European geotechnical research institutes. Asia-Pacific is the clear second block, at 29%, led by Japan, Australia, South Korea, China, and India, and concentrated in seismic and foundation engineering. The Americas contribute 13.2%, and Middle East and Africa 7%. Smaller but growing contributors, led individually by Mexico, Brazil, Turkey, and South Africa. Ranked by paper count, the United Kingdom leads with 102 papers, followed by Japan with 98, Germany with 83, France with 66, and Italy with 62. The United States, Australia, South Korea, and Austria round out the top 8, with China, Mexico, India, Norway, Poland, and the Netherlands completing the top 15. Across all 1,257 submissions, Foundations and Piles is the single largest subfield, at 174 papers, 14% of the total. Numerical and constitutive modeling follows closely, at 158 papers, then soil dynamics, seismic and liquefaction work at 146, and site characterization and testing at 138. Together, these four traditional pillars account for roughly half of everything submitted to the conference. But the picture shifts by region. In Europe, with 615 papers, Foundations and Piles leads, followed by numerical modeling and site characterization, a profile consistent with a mature market managing dense urban infrastructure. In Asia-Pacific, the Americas, and Middle East and Africa, however, soil dynamics and seismic work moves to the top or near top of the list in every case, tracking the geography of seismic hazard itself. Foundations and pile engineering remain the discipline's largest single subfield, at 174 papers, or 13.8% of all submissions. Unglamorous but unavoidable, since almost every structure eventually transfers its load to the ground. And the subfield is diversifying, not shrinking. Research here spans winged and under-reamed piles for uplift capacity, cyclic lateral loading for offshore wind turbines, rigid inclusions beneath embankments, and piled raft systems for seismic high-rises. The United Kingdom leads with 18 papers, followed by Japan with 14 and Italy with 13. Reflecting mature foundation retrofit markets, and for Japan and Italy, foundation design tied directly to seismic performance. Soil dynamics, seismic, and liquefaction research totals 146 papers, 11.6% of the total. And unlike foundations or modeling, it is not led by Europe overall. It's the top-ranked subfield in 3 of the 4 world regions: Asia-Pacific, the Americas, and Middle East and Africa. That pattern tracks the geography of seismic hazard itself. Japan and Turkey sit on active fault systems, Italy runs a long-standing national earthquake geotechnics program, and Pacific Rim and Latin American contributors bring their own liquefaction case histories. Japan leads with 13 papers, Italy with 11, and Turkey with 9. An independent, unsupervised clustering pass, grouping papers purely by shared terminology rather than a fixed category list, surfaces several themes that cut across the standard taxonomy. The largest is artificial intelligence and machine learning in geotechnics, at 78 papers, followed closely by energy geotechnics, geothermal and thermo-hydro-mechanical work, at 71. Climate risk, landslides, and satellite monitoring account for 47 papers, digital monitoring and fiber optic sensing, 38, tailing storage facility safety, 37, and offshore wind and monopile geotechnics, 33. Zooming into the digital cluster, 78 papers apply machine learning and AI. Neural networks, machine learning-driven ground improvement design, and AI-assisted parameter calibration appear across foundation, ground improvement, and modeling papers alike. A further 43 papers form their own instrumentation and monitoring cluster, built around distributed fiber optic sensing, real-time monitoring, and the observational method, reflecting a shift from purely predictive design toward measurement-verified performance. And 15 papers address the transition to the revised, second-generation Eurocode 7, a reminder that codified design practice, not just research method, is itself in flux. The ground itself is becoming energy infrastructure. 71 papers on energy geotechnics. Geothermal piles, energy geostructures, and coupled thermo-hydro-mechanical soil behavior form one of the largest single clusters in the entire unsupervised analysis, larger than tunneling or geosynthetics as fixed categories. And offshore wind, at 30 to 33 papers, is now large enough to form its own cross-cutting cluster. Monopile drivability, cyclic lateral loading, liquefaction assessment for turbine foundations, and suction anchor design recur across multiple regions, not just Northern Europe. Risk and climate themes are gaining ground too. 47 papers link climate change-driven ground movement to satellite-based INSAR and remote monitoring, treating climate and monitoring as one connected problem rather than 2 separate topics. Slope stability and landslides, the 5th-ranked fixed subfield overall at 59 papers, is led individually by Italy, reflecting its long-running national landslide monitoring effort. 37 papers cluster around tailing storage facility safety, and 84, the 7th largest fixed subfield, cover environmental and sustainable geotechnics, from contamination and waste reuse to carbon and circular economy themes. Shifting from subject matter to who's doing the work, classifying every author affiliation by sector shows academia leads decisively, authoring 52% of all papers on its own. Cross-sector collaboration, pairing academic authors with industry or government co-authors, accounts for a further 23%. Industry-only papers make up 14%, typically applied case studies from consultancies and contractors rather than universities. And government or public research institutes author 3% independently, with the remaining 7% unclassified from the available affiliation text. That mix varies by region. In Europe, academia authors 49% of papers, with 16% industry only, the highest industry share of any region, and 22% cross-sector. Asia-Pacific is more academia-led at 56%, with 11% industry only. The Americas and Middle East and Africa show similar patterns. Academia in the high 50s, and industry-only participation around 11 to 12%. At the country level, South Africa shows the highest industry-affiliated share at 35%, followed by Australia at 33%, Austria at 26%, and the United Kingdom at 25%, all mature, private consultancy-driven markets. By contrast, several countries with large academic delegations, including China, India, Canada, and Portugal, recorded no industry-affiliated papers at all among their 20-plus submissions each. Pulling the regional picture together, Europe, with 615 papers, is consolidating around numerical modeling, foundations, and ground improvement, with the highest industry-authored share of any region. Asia-Pacific, at 364 papers, is dominated by seismic risk. Soil dynamics and liquefaction rank ahead of foundations, with Japan, Australia, South Korea, China, and India all contributing at scale. The Americas, at 166 papers, are also seismic-led, with a stronger site characterization emphasis than Europe, led by Mexico and Brazil. And Middle East and Africa, the smallest region at 88 papers, is proportionally the most seismic concentrated, with Turkey, South Africa, and the Gulf states contributing, and environmental geotechnics ranking unusually high. Looking at leadership by subfield, the United Kingdom leads foundations and piles, and numerical and constitutive modeling. Japan leads soil dynamics, seismic, and liquefaction work. The United States and Japan tie for site characterization and testing. Germany leads ground improvement, Italy and Japan tie for environmental and sustainable geotechnics, and Italy leads slope stability and landslides. The United Kingdom also leads instrumentation, monitoring and digitalization, and tunneling and underground space. Taken together, 5 directions define where this field is heading. First, the ground as energy infrastructure. Geothermal piles, thermo-hydromechanical modeling, and offshore wind foundations now form research clusters as large as several traditional subfields. Second, the digitalization of design and verification, AI-assisted calibration, fiber optic sensing, and the observational method point toward continuously monitored, data-corrected designs. Third, seismic risk keeps its center of gravity. Asia-Pacific, the Americas, and Middle East and Africa all rank seismic and liquefaction work as their top or near-top subfield. Fourth, academia still drives the field, but industry is closing in. 52% of papers are academia only, but 23% already involve cross-sector teams, with industry-only work concentrated in mature markets like the UK, Australia, and Austria. And fifth, environmental and waste containment accountability. Tailing, storage safety, and environmental geotechnics are now large enough, independently identified clusters to be considered standing subfields in their own right. So what does the data say taken together? ICSMGE 2026's 1,257 papers show a discipline that is simultaneously consolidating and diversifying. The traditional core amount of foundations, numerical modeling, site characterization, and seismic behavior still accounts for roughly half of all submissions, concentrated in the United Kingdom, Japan, Germany, France, and Italy, and driven overwhelmingly by academia. At the same time, independent clustering of that same corpus surfaces a second, faster-growing layer: energy geotechnics, AI-assisted design, digital and fiber optic monitoring, offshore wind foundations, and tailings and climate risk. With industry involvement concentrated in mature private consultancy markets like the UK, Australia, and Austria. Read together, the data point to a field whose center of technical gravity is shifting outward. From the building foundation to the energy borehole, from the single site investigation to the continuously monitored asset, and from national case histories to globally shared risk problems like tailing safety and climate-driven slope movement. A final word on methodology. This analysis covers all 1,257 papers published in the proceedings of the 21st International Conference on Soil Mechanics and Geotechnical Engineering, held in Vienna, Austria in June 2026. Country attribution is based on each paper's stated institutional affiliation. 16 papers, or 1.3%, could not be attributed. Sector classification, academia, industry, or government and institute, is based on institution name keyword matching. 93 papers, or 7.4%, could not be confidently classified, and subfield classification combines a fixed 21-category taxonomy with an independent clustering pass used as a cross-check. This report reflects patterns in published conference submissions and is not a comprehensive industry census.